Okay, we're recording. Hi, welcome. This is Jacob from the Gitaly team. We're doing a little demo about how Gitaly uses Prometheus for metrics. What is Prometheus? Prometheus is a open source monitoring system, and it's what all our dashboards run on at GitLab. So it's our main source of metrics. And the basic idea of Prometheus is that you have a program that you want to monitor, and you define a bunch of counters that program runs in memory. And then once in a while, the Prometheus service that you're running somewhere comes by and scrapes the values of those counters from your program and aggregates them. So it's a sort of pool model where the Prometheus app is pulling from all the jobs, where all the things that export Prometheus data. And so the reason we're talking about this in the context of Gitaly is that Gitaly has such a Prometheus exporter. And yeah, the main thing that this thing is doing, let me switch to sharing my screen. I should have done that in the first place. Desktop. Okay, so the main thing you may know it from is these dashboards where we keep track of our RPC rates and what's going on. All these dashboards are driven by Prometheus data. And let me just click. I was like clicking find commit. So this is, well, the app we're looking at now is Grafana. Grafana is a graph app, and it can display graphs based on data from various backends. So Prometheus is acting as a backend. One of our production Prometheus instances is acting as a backend for our production Grafana instance, which is making these graphs for us. So one thing that's good to know about Prometheus is that this is not the only way to consume the data. This is one of the fact that we can consume the data like this is one of the strengths of Prometheus, but we can also run ad hoc queries. And so let's see for something like the total rate per second. So here it's just a cute little graph. I can create this graph as an ad hoc query if I go to the Prometheus, the production Prometheus instance, and then I can write a query for this. And this thing is an autocomplete, so I start by typing Gitaly, and then I think, no, I should not type Gitaly, because so these are actually, it will be cheating for me to use these things. These rates come from gRPC metrics, and so we want something like gRPC server handled total. This is going to fetch too much data, but I think it's instructive to see what Prometheus looks like in the real world. Right, so what I want to do now is I want to give a short tour of how we use Prometheus, and then I want to give a small example where I add a new Prometheus metric to Gitaly, and I go through the steps of showing what that takes and how you debug it or see if it's working. So yeah, what we have here is way too many metrics. This list just goes on and on. And this, yeah, so let's just see what these are. So this is a counter, and it is parameterized by a bunch of labels. So there's an environment label, fully qualified domain name, and instance, which looks very much like the fully qualified. Well, it's almost the same thing. It's the domain name plus a port number. Job equals Gitaly. Stage, tier, type. I don't know what these things are. But then there's a bunch of things in there that I do know what they are, and that's gRPC methods and gRPC service and things like that. So we can refine a query like this by saying we want to see certain methods. So let's say we were looking at find commit earlier, so I can do this. And what did I just do wrong? Because I got no data. Okay, I'm backing myself into a corner because now we have to redo this slow query. The reason I want to show this is that you see that how many dimensions there are to this data. And this is the strength of Prometheus is that it's fairly simple and that running these counters is cheap. The downside is because it's an in-memory database, you can run out of counters. So you need to pick running a counter in your program, like having an extra counter in Gitaly is fairly cheap, but tracking all these counters in production adds up at this central point, which is the Prometheus server. So as application developers, we have a responsibility to not create new metrics willy-nilly, but to only do that if it's worth it. Now, why was I not able to use a filter here? Okay, and this time it's working. And if I do find commit, it's also working. So now we still get way too many results. And there's a couple of reasons for that. One is that we are listing all the different gRPC codes: aborted, already exists, canceled, data loss, deadline exceeded. So we have, I think there's about 15. So we have a factor of 15 multiplication just for these gRPC codes. But we can just filter on one code and get closer to an interesting rate. So let's just copy paste that in here. And I know that I like the OK code. Now we still have a lot of results, and that is because we are scraping 36 different Gitaly processes. And this is where the query gets a little more interesting. I would now take a sum, and then you get just one number. So this is sort of how you manipulate these things. Now, this sum is not that interesting to look at because it's just a number that goes up. And usually what we care about, so this is because it's a counter. Usually we care about the rate. And the way you do these things in Prometheus is that you store a counter in the database, and then when you run a query, you ask Prometheus to turn that counter into a rate. And the way that you do that is that you put this rate thing inside the sum. And this is some sort of vector notation I don't really understand, but this means that I take the rate per 5 minutes. It's the number that I learned from the documentation somewhere. This language is called PromQL, and there's a help page, and you can find information. But this thing, some rate, and then something, and then at the end, the 5M, and this is what I do almost all of the time. So now here we have a rate, and this is over a 1 hour window. What did we see here? This was 12 hours. So let's see if we can get that same graph. So now we see a graph that starts in the 700s, and then it's between 1.4 and 1.6K. And here I also see about 700, and here we see 1.35, 1.4. So I've reproduced this same graph. And this is not very interesting because this graph was already here, but sometimes there's things that you don't have a dashboard for yet. So one of the nice things is that you can keep, if there's something you know that's going to happen in your code or that you expect is going to happen and you want to be able to query how much it happens, then Prometheus can be a very nice tool for that. Because if there's something that might happen a lot, like multiple times per request, and you want to track it, and if you start writing log messages, you're creating a crazy amount of log messages. And querying logs is very slow. And just the volume of log data we create is very high. So it's usually no fun to get this sort of information out of logs. And if you know that you only care about something, whether something happened or not, then really all you need is a counter. And adding a counter is cheap. And then you can go in and find out interesting things about your code. So a while ago, we added a cache to Gitaly for cat file processes. And it's a cache. One of the basic things you might want to know is, like, is it working? Do we have a nice hit rate? So we instrumented this at the time, and I think we put the hit rate into this thing. So this is now again, these are too many results. You can see that there's a type field where it says dirty, duplicate, hit, or miss. And it's still parameterized by instance. And let's say I don't care about the instance, but I do care about the type. So then I can say something like this, sum this by type. And then I get the counters for these individual states. And we can see how that those evolve over time. And adding these things was relatively cheap, and it was very valuable once it was in production, because we could get an insight into how well this thing is functioning. And well, we probably don't want to see the totals. We want to see the rates. So let me put that vector thing in here and the rates, and then we get our rates. And yeah, there you go. So we get about 1900 hits per second and about 1100 misses per second. And once you have this, you can also do fun things with, like you can calculate a hit rate. So you can take this expression and then I add a division. Then here I narrow it down and say type equals hit. And then here I can say type matches a regex hit. I'd never know how regex parsers work. I hope this is the right regex. Yes, I think so. So this is sort of the total of interactions, like either the hits or the misses, and these are the hits. And this shows us that we have a pretty consistent hit rate that is between 65% and 70%. And another thing, so this is a very nice metric because it shows us how well the cache is working. In this particular case, we also had some weird edge cases where we didn't know how much it was going to happen if we had to fix them. And for that, I should go back to the previous graph. Okay, back button is not working, so I'm just going to recreate the graph. That was the sum without the type and without this. And I wrote by type. And now what am I doing wrong? I took out the rate. I think now she'll be happy. Yeah, so down here at the bottom, you see the two weird states. And in the first iteration of the cache, we actually had this duplicate state happening a lot. And we were able to see that in this graph. And we still see this dirty thing happening about 20 times per second, which is maybe worth fixing, although in the grand scheme of things, it's sort of dwarfed by the normal operation of the cache. So this is, and so what's really nice about this is that this is a simple performant way to get telemetry of how the system is behaving in production. Another nice thing we were able to do, just while we're still here, is that we were able to look at one of the other, this cache is a Lru cache, and we care about how many entries are in the cache. And we can also see that here because we added a gauge. There's only a handful of fundamental data types in Prometheus. One is counters, which are nice for getting rates. Another one is gauges. Those are numbers that can go up or down. And we put that one, I think this is the gauge. Right, and this one, okay, we're actually getting this is a breakdown by Gitaly server. It's kind of interesting to look at the graph. So here you see that, I don't know what this server is doing, but it's doing almost nothing because at any time, like here, it's peaking at 11 CAD file processes. And then most of them are hovering here at around 100. And some of them have peaks. A lot of them have dips. So this is file 07. We can look at this one because it's funny that it has dips.
Jakob, in that
yeah.
graph, it looked like some of the processes had more than 100, but it's capped at 100, right? 100 max.
No, I think we should double check what it's doing. So this is not measuring the way the cache works. Like if you have a cache miss, we create a new process, and I think we are well. clearly
Oh,
we're
so there
not.
can be processes outside the
Yeah,
LRU.
exactly. Yeah, this
Okay.
is, so I explained it wrong. This is not the actual LRU size, because you're right. That has a hard cap at 100. I want to zoom in on one of these processes, and I'm going to use a regex. So this server has some uneven traffic, right? So here the cache is never filling up, and now it's getting close to filling up, but it's actually, the way it keeps bouncing down suggests that this server is not seeing very heavy traffic. And I think if I put an 8 here, I get the server with GitLab CE on it, and that one is pegged at 100. Yeah, so actually this is a nice bridge to look at what this looks like in the code, because these counters, like, what are we actually counting? Good question. So let's take a look. Well, let's look for the cat file cache. So this thing is called Gitaly cat file processes. I think I can just find this string. There we go. So this shows you what setting up a Prometheus counter looks like. You create instances of counters or gauges from the Prometheus package that you want to store in a variable, because well, you're calling a function, so you have to store it in a variable. And these things you usually make a global. These will be global variables inside your package that are private to your package, and they don't do anything because they still need to be registered at runtime so that they get exported from the HTTP listener that Prometheus has. So the pattern is you have a variable declaration where you call some constructor on the Prometheus package to create a counter or a gauge. And then in your init function, you call Prometheus must register. Without that, if you just declare the variable, like, the thing will never get published. Okay, so it was this one. It gets registered here, and we don't manipulate it in this file. So whoops. Let's look outside this file. Now I'm being a dork with my mouse. Let's see. Okay, there's an increment and a decrement, and that's it. It's the only thing we do with this thing. So when do we increment? When we spawn a new process, and we decrement. Yeah, so this process has, let's see, what is the context here? I think this context that is coming in here is strictly tied to the lifetime of the cat file process. So this counter is really tracking the lifetime of the process, and whether or not it goes in the LRU is because if traffic exceeds if there's nothing in the LRU, we're still going to make a new process. So that's why this can spike. Make sense? Yeah. So now we're looking at the code, and now I want to look at an example of adding a new counter for something fun and what that looks like. Because it's the one thing that is not, it's slightly, if you know how Prometheus works and if you know what to look for, then adding counters is easy. But if you don't know, then it's not obvious. And I think the main thing that I don't have a good story for is how to see if your counter is working. And the only answer I have to that is boot your stuff in GDK and scrape the Gitaly process in your GDK, scrape its Prometheus values, and see if you see your counter moving. And if it's moving, then it's working. So it's a sort of manual verification process that we don't have nice testing for. Maybe there is a nice way to test this and we just don't know about it. But
So at the Go level, there's no API for checking the current status of a counter?
it's a very good question. There probably is. We should look for that. I'm going to show you my I'm going to show you my dumb way of doing it. If there is it would probably be nice if there was an API, but well, it depends a little bit, because sometimes it depends on whether you can force something to happen or not, because sometimes you want to count certain exit paths or well, let's just go through an example of this way of doing it, but you're absolutely right. We should look for a Go API to check this. So my idea was that to stay in this cat file world, we have, let's look. we have this thing where, no, this is the wrong process. So cat file is our Git object lookup abstraction. And there's only 4 Git object types. Like how many times, at what rates do we look at the individual types up? So this is a good example of safe use of Prometheus, because there's only 4 object types. So if we create counters for these 4, we know that it's a bounded, reasonable number. The one thing you never want to do is to create a counter that is parameterized by, say, the project name or the project path, because in production there is in the order of 1 million of projects, and we don't want to create 1 million time series in the memory of that one poor Prometheus server. So whenever you parameterize a Prometheus thing, always think about what are the bounds for the values that we got here. All right, let's see. So maybe this is the class I want to be in. Yes, this is the class I want to be in. So my idea was, we have these convenience methods here: tree, info, commit, blob, tag. And so info is a bit different. It corresponds to looking up the attributes of a Git object, but I think it's interesting to count that too. So I want to count those 5 things. So that was my idea. I'm going to set that up now and test it and see how it works, and then query it. Sounds good? Cool. So I always forget how it works, and then I just look for another Prometheus counter and I copy paste that. I know that I want to counter with vec with a vector, which means that it's not just a single counter, but it's parameterized. So I'm going to copy paste this and give it a new name. What is this going to be? Cat file lookup counter, and let's call this lookups total. And git cat file lookups by object type. And yeah, type is not a very nice label, but because it's too vague, but I'm going to stick with it. So this is enough to create the new counter, and I need to remember to register this. Oops, so I'm going to copy paste this line, put this object in here. And now I need to manage this counter. I need to use it. So I'm just going to throw that in here manually. And I think it's called with label values. Yeah, that's how we do that. So I'm going to call this info. And I'm going to manually copy paste that in here. Not the most elegant solution, but I'm not sure if there really is a better solution for us to programmatically say we're in the commit method or we're in the blob method. Okay, let's see if this builds. Because now we get to the point where I do my silly manual verification. I don't know if it's silly, but the process I know. So first I want to know if it compiles. It compiles, that looks good. And I've got GDK running already. Here I have a GDK window, and my Gitaly is broken out in a separate terminal window. So what that means is that in the proc file, I commented out the Gitaly line, and in this window over here, I am running Gitaly manually, feeding it the config file at the GTK root. So for this to get updated, I need to run make Gitaly setup, which I don't know if it still makes sense that we do this, but we haven't gotten around to making this simpler. The reason we have this is that we, I don't remember exactly. We wanted to somehow decouple the Ruby code a bit. I honestly don't remember why we did it like this. I don't know why we're not running out of the main Gitaly directory, but we're doing this. So let me reboot my Gitaly. And first of all, let's see. Okay, do I show you the beginner-friendly way of querying this or the beginner-unfriendly way of querying this? Well, I'm gonna show the simplest way of querying this. We know that, well, we don't know. Let me show you. In the Gitaly directory, there's the config file, and in the config file, we have in GTK a standard Prometheus listen address configured. And this is more or less our port. So also in the production install, Gitaly's Prometheus listener is going to be on port 9236. And this means I can do curl localhost 92336/metrics and get this, which is a bit much. Remember that this is these are all the gRPC counters, and remember that these are multiplied by the number of RPCs and the number of possible codes. And we have about 140 RPCs and about 15 gRPC codes, and I have a very slow terminal, so it takes a long time for 15 times 140 times 2 things to scroll by. So regardless of how fast your terminal is, this is too much. So the next step is, once you have this curl command, I'm going to add silent here because I know that from experience, and I'm going to grep for lines that start with Gitaly because I don't want to see all that stuff. And I already get some stats. So there's 0 processes in my cat file cache. It's never been used. The health checks are running. There's some bad and good health checks on the Gitaly Ruby processes. And we are tracking the memory of the Gitaly Ruby processes here. So now, if I got, it's kind of boring if I got it right, but if I got this right and I start browsing localhost 3000, then we're going to see numbers for cat file. So let's see if that works. I expect this. Okay, it's not going to print access logs now, but we loaded the page and this has to look up some Git data. So let's run that curl again. And there we go. 6 blobs, 66 commits. We called the info method 154 times and 41 trees. It's actually quite a lot already. And this is the simplest way to verify if your counter is working. You have a theory about when it should go up. You use curl and grep to look for your counter. You trigger the behavior when it goes up, and you see if it went up. The slightly nicer way to do it, or the different way to do it, is to run the Prometheus app locally and have it scrape your Gitaly process and then plot the data. This is not the best fit, actually, I think, for development use, because the rates are usually going to be 0 in development, because look at me, I'm yakking, I'm not clicking. Nobody's clicking on my localhost 3000. So nothing's happening. But let's take a look anyway. I have it, I have Prometheus up here, and I hope that it will now, yes, it put the lookups in the autocomplete, and we see the numbers here. So that's cool. And you can see this is kind of stepped. That's because my window is very long and it goes in 15 seconds. Actually, it's stepped because of the clicking, because I'm not clicking. Let's make this shorter. Let's say 15 minutes. And let's click some more. Let's click another project. File. That's still loading. And these numbers are going up already. And they should go up expect them to go up another time because the scraping interval is 15 seconds. This is the sort of standard Prometheus interval. So you're never going to see more resolution than a change once every 15 seconds. And now this is leveling off again. So if I would take the rate of this, I think I can just plot it like this. My queries are easier because, oh, that's funny. I would expect them to drop to 0. How can this rate be at 1? No, it's not because I didn't do a sum. I have no idea why these rates are not 0, but they're not. But my point was, you can also launch the web interface locally and run your queries and have a friendly way of exploring what's going on. I know this thing well enough, and I'm just lazy, so I do it with curl, and I see my counter go up, and I move on. But if you're learning something new, you might want to also. It's nice to have this, and this is nicer to look at than curl. So this thing where it says console, this is more or less what you get in curl, right? And this is a snapshot of the current values of the counters for the query you ran, and graph plots them as a time series over time.
Hey, Jakob, do we have any kind of test helpers in Gitaly for like setting up the Prometheus web server and then hitting the web API to do what you did, but in an automated fashion for unit tests?
No, we don't. I think this has to do with our the way we do tests, because most of our RPC tests just boot, they instantiate a gRPC server object that then listens on a Unix socket or something, and we boot a super minimal RPC server that is just the service class, and that will not have the Prometheus listener. This is a good question because it steers me, it invites me to show you where we set up the Prometheus listener, which is why this is not part of. When we look at this, you'll see why this is not part of our tests. I'm not saying it shouldn't be, but it explains why it currently isn't. So where is this? Where's this Prometheus server set up? We've been refactoring this stuff, so we have the main executable here. This is a pretty long file, and this is the class prom HTTP that has this server. So somewhere down here, this is the main function where we register listeners, and so we had to create special hooks in the we have the bootstrap of the main process is a bit complex because we can do live reload where we do a failover between an old and a new process. So we had to add some abstractions there, and those abstractions have a special way to plug in the Prometheus listener because it's not a gRPC listener; it's an odd duck in there. But this is what it looks like. You call this thing and you get a handler, and because all those init functions in the packages have already registered their counters, this handler will now know how to serve all those counters. But by the time this method runs, all those init functions have run already because of the way the import order works. And the standard way to mount this is at /metrics, but you can mount it anywhere because it's just an HTTP handler. And we throw that off in its own Go routine. And another thing that is worth knowing is that somewhere, but now I'm wondering where, did we lose that? Because we used to also, no, look, we also throw pprof on here. Pprof is the Go profiling server. So you can also do, this is easier to see in the web browser. Actually, let's just look at 9236 in the web browser. So this is that curl I showed you earlier. So this is all the metrics. By the way, this is Prometheus. This handler can also respond with protobuf. So the Prometheus scraper actually uses protobuf because it's more efficient. But this is great for curl and grep. So this is the text version of this thing. But if we go to, is it debug? I think it's debug vprof. So this is on the same listener. Once you got to localhost 9236, you can also do this stuff, and you can look at your allocations or your, well, all this vprof stuff. So that's also nice to know. But also, like Prometheus, this is only loaded when you boot the official main of, like, the real main of the application. And I think that if you wanted to check these counters in testing, I don't know if Prometheus has methods for this, but it would probably be nicer to not go through the HTTP front end, but just talk to Prometheus somehow using the internal library. Using it feels a bit roundabout to go through the HTTP endpoint, and we know the HTTP endpoint works, I think. Well, I never really thought about this. It's pretty critical, but we only hand test it, and we put these counters in, and they usually just keep working.
I guess the web server would be a good way to go about it if we can't do it through a library in the same process space.
Yeah, it would be a last resort, and it means that there is some way to get to it. Yeah, I agree. Yeah, good question and good idea. So this is, I think I showed you. Okay, there's one more thing I can tell you about that is sort of interesting. You may have noticed that there are latencies on these dashboards, and these latencies are also monitored with also based on Prometheus data. And the thing is that the resolution and the fidelity on these latencies is not great. And this is because the measuring latencies, so Prometheus is a tool that pre-aggregates. And if you want to pre-aggregate latencies, if you want to do it right, you need to sort of know what bandwidth they're in. And you want to have buckets and just count the different latency values in different buckets. We're using histograms here. So you would have a histogram, and then if you know what to expect, you can get a nice accuracy and good insight into the real numbers if you can pick your buckets well. But we have one set of latency buckets for all RPCs, and some RPCs take 5 milliseconds, and some RPCs take 5 minutes or 30 minutes. So what we ended up with is exponential buckets in our histogram, which is kind of not nice from a histogram math viewpoint. So these numbers are almost always not quite right. So to see that, for example, so here we have a reported P99 of 24 milliseconds, and we can compare that with ELK, which oh, I hope this is not going to flash private data. Please don't do that. Okay, I clicked fast enough. If you load ELK, it goes to the Discover tab, and you just see last bunch of log entries with private data. I want to make a graph, and graph won't contain private data. So I always create these graphs from scratch because I guess I have to. There's an index for Gitaly, and we want the GPRD, that's the production index. And then I use filters. So and I use a filter on the methods. So gRPC methods. And suppose we want to look at find commit because that's the tab we had up. And by default, it will give us a count. So in the last 15 minutes, there's 1.3 million wow, 1.3 million messages that are labeled, structured log messages that are labeled with find commit. And I want to narrow this down a bit because I only want to have the lines at the end of the request. This is not making a difference. We're still at 1.2 million. And now moving away from the count, I want to see percentiles, because my story was that the Prometheus percentiles were fishy because we have funny buckets. So time in milliseconds, 99th percentile. And then on the x-axis, I need a date histogram. I don't really understand what I'm doing. Somebody just showed me once how to make these graphs in Elk, and I remembered. Now I'm showing you. And I click play. And then we see a P99 of, well, this is more like a, well, it's spiking here at 22, but this is more like 15, 14. It's much lower. This is a very long window, 12, but I think, well, let's see if Elasticsearch likes it if I ask for 12 hours. It's still in this band of 14 to 16. So our P99 is actually, in this case, it's better than what this dashboard is reporting. And the likely reason for that is that because we're using histograms, probably the buckets are at 10 milliseconds and 100 milliseconds, and then we're using a midpoint of that in the somewhere in the calculation of this P99. But that taking midpoints like that in exponential buckets gets you wonky results. So what am I trying to say? These latency numbers say something about latency, but don't take them literally. If you really want to know P99s, you have to look at the logs. Something else that's interesting about Prometheus that we're not using very actively right now, it's also because of the way our team functions, is that Prometheus is a built-in function where you can define alerts, because you're tracking these time series and you can define queries, and then if the query returns a result that is greater than 0 or whatnot, you can have an alert go off. We still have some of those alerts dripping into our team channel. This made sense when we were still in the infrastructure department and we were empowered to act on these alerts. Right now, we can only run to the SREs and say, help, there's an alert. But this is another nice feature of Gitaly. And it's not something that we interact with much as application developers, but once, if we put good metrics in there and if they're out there, then our SRE colleagues can define nice alerts based on that. Okay, and there's one more thing that I keep forgetting, and that is where I was showing you all these gRPC metrics. They come from a middleware. So actually the bulk of our metrics comes from a middleware, and that is defined in the internal server, or that is loaded here, server.go, and that is this one, Go gRPC Prometheus. So this thing, I think it automatically analyzes, it is something smart with introspection. So you might like whatever it's, you might understand what it's doing, Paul. It's doing something smart to figure out what the all the methods in our protocol are, and it predefines counters for all methods multiplied by all possible gRPC codes. And we can look at this project for a moment.
It was the codes, and then it was also different attributes, right? Like the name of the method and.
Yeah, although those are unique combinations. Like it's breaking down, every RPC lives in a service. So it's service plus RPC, and it breaks it down into a service label and an RPC label. But we're not repeating the same RPCs in multiple services. So those don't contribute to the cardinality. Yeah, so we're using this thing, and this is also where our latencies come from. Yeah, so this is actually the bulk. Like all those dashboards are really based on this. This thing is automatically instrumenting all our RPCs and running counters for them. And the other nice thing is that you may have noticed is that our dashboards automatically pick up on new counters. And I think that comes down to this middleware somehow being smart about detecting all the methods, and it starts automatically publishing counters even if there's been 0 requests for something. And you may have noticed that if you look at the, I didn't make changes, discard. This wall of tiles has gray tiles in there once they load. Well, this is not really gray, right? This is getting some traffic, but apply BFG object map is apparently not happening. But that middleware is exporting the numbers anyway. And if you create a new RPC, it automatically shows up here because the gRPC middleware starts exporting counters for it. And this dashboard is defined to create a tile for every counter, every RPC that has a counter for it. So that's where that, you won't have to touch this, but that's where it comes from. So now you know how that works. Anything else we want to look at or discuss here?
I have a question about what kind of numbers work well for counters. So when I'm looking at the Go code, the library, I see that it's a float 64 and then it gets converted into an int 64. So in my mind, anything that can go up to a 64-bit value is something that's up for grabs as a counter. Is there anything you know from experience working with these on, what types of numbers work well as counters and where the limits are, and also regarding how this works in memory in the Go process? Like, what do we have to avoid to run into not get into performance problems when we're tracking different counters?
From my experience, we never have to worry about the performance of running these counters in our own process. Prometheus does smart things with overflow, or wraparound. So if your counter wraps around, it will still calculate rates correctly. And I've never run into a problem where we were going too fast for a Prometheus counter to keep up. I think it's the challenge is more about recognizing things you can count, because or things where it makes sense to count, because we say you're looking at the problem is that because these are counters, you're sort of doing a pre-aggregation, and you might end up counting things that are so you often end up with an average. So suppose we would count the size in bytes of all the outgoing RPC messages. I think maybe we are already counting that via the middleware. I don't remember. The only thing you can do, you miss out on some granularity on that, and you can easily end up with things where you only see an average, or you cannot see difference between outliers, or like the if you want to see outliers or weird behavior, or things that are using. If you want to zoom in, yeah. If RPCs are slow for only some requests or some repos, and you want to detect that, then these counters are not a good tool for that, because that will just disappear in the noise of the averages. And that's why you also need the log data. So I guess my preference is to use it for discrete things, and more like more general things like that cache data structure. Like, how is this data structure behaving, and what are the what's also nice about that data structure is that it's global to the entire process. So that makes it a good candidate for this, because if you want to track anything at the project level, you're going to get a number across all projects that gets RPCs called on them. I'm not sure if this is making sense. It's something you sort of have to it's something you have to sort of figure out or learn, like which things these counters are appropriate for. I'm not good at explaining it. I can't put it into words well.
Just got to know.
Well, and look at examples of other things we count. It's working great for these RPCs. These RPC rates are very nice, and because the counters are labeled by server, we can also break them down by server. Also, the server metrics we get for memory use and CPU load and all that stuff is also Prometheus counters. Okay, well, if we have no more questions, then let's see if I remember how to turn off the recording. And thanks for joining and asking questions. And good, I should say goodbye now. Is the stop recording? Okay, bye.